Hi, welcome back to an artifact review video for Team 12 developing the ARKnee app. This is artifact review video 7 for Sprint 7. So, getting right into it, our main goals for the sprint were to get the core components of our game environment completed, work on some of the supporting aspects for that, including a centralized controller class, really hammer out a lot of the modeling that needed to be done for in-game assets such as the leg and shoe, and finally to research into ways to improve image target tracking over the distances needed, including alternate methods like using colored LEDs in place of image targets. So jumping into the game environment, you can see in the background here we have our Unity gameplay scene set up. So we've added a terrain, which in this case is just functioning as a flat ground plane. It's been textured using a simple but nice looking grass texture that is free to use, courtesy of the Unity Asset Store. Now what's nice about this is it looks great but is very low on resource use, which is a concern since this is a fully rendered 3D environment that's going to be deployed on a mobile device. In the same vein of conserving resources, instead of implementing a full-blown skybox with all sorts of cool lighting effects and everything else, we've opted for just a flat 2D plane textured with this nice image of clouds. You can see how that's going to look in this little camera preview box down here. Since our camera view is stationary and is not going to be moving whatsoever, it doesn't make any sense at all to spend the resources to do a full skybox. Another improvement in the gameplay environment is twofold. Our sponsor has asked us to include a visual indicator of tracking status, so when the trackers are lost, the screen will flash red. So we've added a border around the edges of the screen that will show red when tracking status is lost and will fade back to transparent once that tracking status has been targeted. And for our own use, but this may be included into the final version depending on what our sponsor thinks, is these three boxes here that are going to represent the hip, knee, and ankle respectively, and they are going to turn green when tracking is good and red when tracking is bad. We added this in to aid in our testing for tracking distance, so we have a quick visual indicator of which targets are currently tracked and which are not currently tracked. We've also added a pause button, which pauses not only the gameplay, but also the Vuforia and the AR camera, and we'll go ahead and bring that up here in just a second. Go ahead and launch this. Alrighty, so you can see our gameplay scene looks a lot better now that we have this ground plane and skybox. Of course, the goal and net are going to be rendered in here along with the leg itself, and then these three red spheres, which are just placeholders representing the position of the joints, is going to go away. Likewise, the pause button is just an arbitrary location for the time being until we work with the sponsor to determine where that and any other menu items should be based on whether we implement voice recognition or whatever game controllers ends up being used. So let's go ahead and, if you take a look, the tracking status for all three trackers is going to be red because, of course, there's no trackers on screen. So I'm going to go ahead and bring a tracker up here. Boom, and instantly you can see that tracking status has been recognized, or the tracker, rather, has been recognized by Vuforia, and the tracking status has been updated to green. And I'm going to drop this out, and you're going to see that this turns to red, and then we get that red border around the edge of the screen to appear. If I bring this back up, oh, the red border fades away, and then this square turns green again. So I'll do that one more time. Alright, so I'm going to go ahead and pause real quick. Now you can see that the AR camera viewport and everything else has totally been paused. And then if I resume, Vuforia is going to reinitialize. It's going to correctly reassess that there's no target on screen, and put the red border up and change the box to red. Likewise, if I pause, bring that tracker back, We're going to see it resume its previous state and then reinitialize and pick up the new tracker here. So there we go, boom, everything's good to go. Alrighty, so I'm going to go ahead and just back out of that real quick. Alright, before I move on to our code base, I just wanted to mention some of the research we've done looking into improving tracking distances. So we are going to have a mini sprint over spring break, and that's going to focus on redesigning our trackers to work at a greater distance. From our research, we've found that bigger, blockier geometry should help, because it'll give some very clear data points for Vuforia to hopefully pick up those trackers over a bigger distance. We did also look into some alternate methods, such as using colored LED lights, and found that it's really not possible through Vuforia. So unless we want to scrap Vuforia as a whole and work on doing something either through just the regular ARCore or ARKit frameworks, or another third-party framework, that will remain to be seen, but it is an option. Alright, so first off, just want to look at the progress on the models we've been doing. So here is a screenshot of the leg in Blender. It's not textured or smoothed or anything else at this moment, but the purpose of this is to show how we've been trying to keep the number of polygons down to a minimum, again, since this is going to be running on a mobile device. And then here is a close-up of the shoe object itself. So the next step is going to be just importing these into a project and then just rigging up that leg and attaching it to the leg geometry and those joint objects that we showcased in the last video. So we have all the positional information there. Just need to rig up that leg and we should be good to go. So moving on to our code base. The biggest change here is going to be in our controller class. The main idea behind this is that we want to have a centralized place where everything is controlled from, and we don't want to rely on Unity initializing and running scripts when Unity thinks it should. We want to control that ourselves to make sure that Vuforia is 100% initialized with a good-to-go status, that we have good tracking data before anything else happens in the game. So we want to kind of control each step of initialization before even the main gameplay loop starts running. So that's what's been done in a lot of this class, including some of that pause functionality you just saw. Just to touch base, this is our own extended trackable event handler from the Vuforia API, and this just shows how we use this pretty neat linear interpolation method to get that effect of that red border fading back into transparent, and then this is just setting the green or red textures for those boxes on screen. So there's just going to be a quick transition here while I set up Unity to go showcase some of the physics collision stuff that we've worked on. Alrighty, so here's just a quick showcase of some of the collision physics that we've implemented. We will be showcasing more of this in the next sprint, because that's going to be the major focus of that sprint. But just as a little tease, now that we've got the ground plane set up so we can do collision-y stuff, here's just a simulated ball bouncing off of an angled cube and then bouncing away on the ground plane here. So, let's see what happens. Alright, not super exciting, but it is a pretty neat step forward. Well, thanks for tuning in. We will go ahead and see you in the next video, and we're excited to show you what we can get done.